Next, we have actually two speakers for the session. It's exciting. Remote Persistent Memory Access API. The two speakers are Tomasz and Jane. They are both from Intel. They both work at Intel's memory and storage product group. Their focus is on remote persistent memory access, which includes proper integration of persistent memory with other networking technologies, as well as optimal persistent memory replication procedures and algorithms. Tomasz and Jane, welcome. I will be unmuting you now, so let's go ahead and give it a try. There.
Hello, everybody. Good morning, good afternoon, good evening.
Thank you.
Yeah, we are from Poland, so in this case, it's our late afternoon. Yeah, but anyhow, thank you for accepting this presentation, and I'm very glad to speak this year. Last year, I attended only as a normal participant, but today I would like to, together with Jan, which is my, let's say, partner in work, I would like to present our evolution of our approach to software solutions for remote persistent memory access. So next slide, please. Yeah, so first of all, very shortly, what do we understand by this remote persistent memory? In short term, the RPMEM, where it comes from. And what is the difference between RPMEM and other technologies? First of all, for remote persistent memory, we use RDMA. But it is not the unique, as there are many other data replication, like for example SPDK just also uses RDMA. But the most important thing to express the difference here is the word direct. In case of RPMEM, there is no buffers in the replication pipeline. So any application can put data directly into remote persistent memory with help of this RDMA technology. So access to remote persistent memory is handled in the same way as it is done with standard memory. The only problem that it's known for RDMA folks is that it doesn't natively understand the persistency. So a consumer can read and write remote persistent memory with standard RDMA verbs, but writing to remote persistent memory doesn't ensure immediate data durability. A user must perform additional actions to guarantee that the data are stored in the persistent memory. So next slide, please. So there are two most common way to move data between two nodes when we talk about persistent memory and also other replication technologies. We have this so-called pull method based on traditional RDMA verbs. When there is a software running on the target node, the node where the data are stored, which is asked to obtain data from the INITIATOR node, and it sends confirmation when the data are locally stored in the storage. And there is a second, we call it the push method, when the initiator node is only the one that is responsible for the whole replication process. So either with existing verbs or with new coming verbs that are under design process, it's possible to push data to the remote node without any CPU involvement in the target node. And as you could see, there is much more, so we could process much more data at the same time. We could also do not spend so much time on the waiting for the replication process itself. Also, the target node CPU power could be saved for some other tasks. So next slide, please. And this is what has been implemented in one of the PMDK, so Persistent Memory Development Kit solution with librpmem. We use this push method when the target node is almost not involved. And with very simple API, with almost two call RPMEM persist and RPM read, we are able to cover all the complexity of RDMA protocol and all these different options that we have to support. Depends on the platform configuration. So this is our first approach. Yeah, we have two calls, one for reading, one for writing remote persistent memory. Please, next slide. And of course, it's also a need to have some API to manage the replication process. So in this case, we hide everything which is related to connection management. So basically, we have API to fully control the remote persistent memory, to create the remote persistent memory, open or close this area of remote persistent memory, and based on that, we could also we could use this remote persist and read operation on the top of that. And in this case, we use SSH for out-of-band connection. So this solution is similar to one used in other PMDK libraries. This is common for librpmem and librpma. So please, next slide, please.
I think we lost Tomasz. I don't. Oh, there he is. You're there? Okay. Yeah, I see you. Hello?
Hello?
Yes, we can hear you. Go ahead, please. No, okay. You're there.
Yeah, okay. Please, next slide. Yeah. So for sometimes we just start to figure out why this approach is not acceptable by our potential customers. So we just ask them and collect the feedback from potential users of these RPM solutions. And as you see, the API was very simple, but it was too simple. It doesn't give the full control of the replication process to the application. We would say cover too much from the complexity. The second problem was that we use this pool set semantics when we build the configuration of master and slave replica. It means that this both memory areas must be binary compatible, and people do not like it. librpmem solution assumes a static configuration that is not acceptable in common cloud solutions when we could change configuration online. And due to some technical decision, we are not allowed to access the data, replicated data. And also, there was a limitation that we are not able to use other than RDMA write and read API for application. And that was a big claim because application would like to share the same RDMA connection for reading and writing, but also for some sending and receiving channel for bookkeeping. And finally, yeah, we are asked not to use libfabric and SSH in our solution. And based on this feedback, please next slide. We have decided to build completely new API with completely new library on the top of libibverbs library that will provide the memory copy-like API for remote persistent memory. Our goal is to hide everything which RDMA complexity could bring out. We reuse the core of the librpmem algorithms because, well, we know how to implement replication in a very effective way. The librpma is designed in such a way that it's ready for new coming verbs. So you will see them on the API. But the biggest change is that management of persistent memory we left for application. So we do not touch it at all because we identify that this is the application to decide how to use persistent memory, and the replication is only one aspect of this usage. So please, next slide. So the core of our library is, well, doesn't change. We have the read, write, atomic write, and the flash operation. Well, there is no magic. This is what application we will use in majority of its time. But also we have the set of functions of functionality to support connection management. As I mentioned, we try to hide RDMA complexity, but anyhow, it's somehow compromise between the simplicity, but also flexibility, because we have seen that we do not know every context in which persistent memory could be used remotely. There's many different scenarios of how application would like to use what is responsible, who is responsible for connections, etc. So this is a compromise. Then we extend the previous solution with messaging system, also that can be used with persistent memory. And as I already mentioned, finally, we decided to not to touch persistent memory management at all. This is application responsibility, how it is configured by applications. And we are only deliver some basic support of functions that help end user to register the memory and to use them in RDMA traffic. So next slide, please. So now let's come to describe the API more details. So first of all, the core, the most important, the right to remote persistent memory. As you could see, we have we have source and destination point. We have two offsets. So in this case, these two memory areas are not needed to be fully binary compatible. For there's a size, and then there is this completion flag which says as I would like to get some feedback, or we would like to put some numbers of operation in pipeline and then only get completion of the last one. We have separate API for 8-byte atomic operation that can be used to update some pointers in an atomic way, for example. And then we have this RPMA flash command that it used to ensure that the data are stored in persistent memory, finally. Then, of course, read operation, very similar to the write one, with the destination offset and this source offset and size and completion. And then separate API call to collect completions. Our library is going to be used either in a very simple application or more advanced, more complex solutions. So this next completion function could be used in non-blocking or blocking mode. And the next completion will deliver completion when it is requested. For example, you would like to know where the flash operation has finished, but also deliver us every completion in case of whatever error state. So for errors, for any fault of execution, we also get completion with error description. So next slide, please. Okay, this is everything what we do about the memory management. So we assume that with whatever library. It could be the part of other PMDK libraries like librpmem or librpmem obj. Somebody would like to reserve memory and then deliver to us only the void pointer with size and information, is it a persistent or not persistent memory, and also give us information for what purpose this memory will be used. And that's all. We do not touch it. We just use this memory as it is registered by application. So finally, we will also have some API to support serialization and deserialization, this so-called memory handle, to help application passing this handles between two peers. Next slide, please. So we also provide on the API set of functions to connect either on the active or passive side. Also, this API could work in blocking or no blocking mode. We are also able to reject application on the so-called listening side. The API is, as I mentioned, prepared to work in very simple scenarios, single thread, but also in more complex solutions where several tens of connections must be handled by one node. Next slide, please. And active and passive terms are only for connection setup, but as soon as application established connections, it's both sides of connections are equal, so they have to monitor the status of the connection just to be indicate, for example, about some broken connection. And there are also both sides are allowed to disconnect from the connection. For using this library in IO-scalable solutions, we provide a set of API function calls to use the to configure the library to use as a non-blocking or blocking API. And finally, we do not have any relation to any other persistent memory related library. We just provide API to configure what we assume must be configured for proper remote persistent memory access. So next slide, please. And finally, as I mentioned, we also have the API for receiving and sending message. In this case, it's possible to use the persistent memory as a main payload of these messages. This is what we have learned from some our potential partners, that this is API that is needed to reduce the latency of some remote operation. And please move to the next slide.
Hey, Tomasz, there's a question from the audience.
Yes, please. Yes, please.
Lance, go ahead, please. Lance, you're unmuted right now. There, we can hear you. Yes.
Very good. I thought that we would wait until the end, but okay. If I understand correctly, you implemented a completely separate library for the verb support, only leveraging algorithms and not any common code. So the question was, how will the libfabric implementation continue to be supported and kept consistent with the verbs implementation?
Yeah, that was what I expected. Thank you for this great question. So, as I already mentioned, it was one of the requests from customers, potential users of persistent memory, to remove, in this case, the libfabric dependencies. And from another side, the PMDK team will support libfabric library, and we are in close loop with libfabric people to provide proper, let's say, API, proper approach for libfabric to access remote persistent memory. The difference, I think, between the libfabric and our library is that in this case we focus only on remote personal memory access, and mainly just to help people to utilize this technology in this application. The PMDK team key goal is to support customers to enable the application for a remote persistent memory. And believe me, in many cases, we have to solve two problems. First of all, to introduce completely new technology, like persistent memories, but also at the same time to adapt already existing application for RDMA technologies. A lot of replication are still based on TCP/IP data, and many people do not have competence on both sides. So we decided to build very simple library that cover the minimum. But libfabric will be supported by us also, and we will not die this library because of the persistent memory.
There's also another question, if I may bring it up now, which is,
yes,
what is the objection or dependency on libfabric that you are trying to avoid? What is the downside of using libfabric?
Well, basically, it is what I remember from our discussion. It's a one more item, but for many customers was visible as a additional maintenance cost. This is, I think, the strongest argument they put. Is it possible to not use it at all, and to avoid that in long term maintenance this in our server? I think that this is. Well, some of them also claim that some performance issue, but this is I don't want to explain to extend in yeah. So basically, I think the maintenance cost of this solution, just they would like to have some very simple application.
Okay, thank you. I have a few other questions coming in, but we can wait till the last 5 minutes. Go ahead, please.
Okay, thank you. So I already start, the questions from Lance, thank you for this. Already start to answering why we build this application, when we propose this library. Yeah, just to help people to merge this RPMEM technology into existing application. Not everybody would like to spend time to introduce the persistent memory and RGMA. And this is the key point in this library, to give something to the people that they will be able to, with very small effort, to integrate in this application. And so I propose just to take a closer look as this API looks in practice. So if you just can go to the next slide to the example. This is how we can use the API in very simple application when we are going to write something. It's just a part of snapshot of the code. So the context is that we already have the established connection, and we would like to write something to remote persistent memory and to ensure that it is stored there securely. So first of all, we just execute this RPM write command in context of some connection with some user context, just to identify later on where this what was the initiator of this write. Then there's so-called memory handle, destination and source, offsets and size, and then this completion flag. So in this case, we do not expect that our library would produce any feedback to application that the write operation has finished. But it is completely different if we move further to this flush operation. When we use this flag, and in this case we expect that the library will inform the application that the flush operation has finished. And in this case we use this flush for the persistent. So in this case, yeah, we have to call just RPM next completion and waiting, because In this case, it is blocking operation, and we are expecting that we get completion for a flash operation and with OK status. So in this case, it means that the data are stored securely in the remote node after the flash operation succeeded there. So next slide, please. So this is a very simple way, example how to register the memory. So there is some, okay, in this case, we just use the PMEM2 library for obtaining the percent memory. We just create a handle for that. And in this case, we decided that it will be an area where the remote node will write data. So when we create this handle, we could convert it to the buffer of bytes that could be easily transferred to the remote opposite node. Next slide, please. And then if you look at this second line and the opposite node, or we are, first of all, we are able to deserialize too. So it means that we are able to obtain the remote handle from the receiving data. And the first line here, this bold line, shows that we are also able to use our library in the scenario when we are writing to remote persistent memory, something that is locally placed in the volatile memory. Yeah, so please, next slide. And this is a very simple snapshot of code that it shows how we are going to set up the connection. And this code also shows the amount of information that we would like to obtain from the application about RDMA. So in this case, we expect just the very basic parameters, in this case sizes of completions, receiving and sending queues. That's all what we expect from application. The rest should be covered by our by our library. And that's all for today. Thank you.
And we have one question.
Yes, I know. So if you have any more questions and you are not covered, please join our website or our GitHub, where you could put issues and could comment our API. Do not hesitate. We are still open. We are not as far as SPDK. The library is now under development for us, so we are still open for comments and feedback from potential users. Yeah, so please, there were some other questions, so I'm ready to answer them.
Thank you. The question is, why not use RDMA write with immediate data plus waiting on the completion channels so the receiver will not do busy polling?
Yeah, this is the one. Yeah, this is. Thank you for this question. I think that this is a point. So we find the problem is when we think about the performance and when you think about the timing or latency, every software that is on the remote side involved in the replication process at not only 1 or 2%, but could increase the latency by 20 or even 30% of the whole performance numbers. So we try to avoid software to be involved in the replication process as much as possible.
Thank you, Dimitri. If you have any thoughts, let me know. I can give you an opportunity. But yeah, that I think it answers the question for now. Any other questions? Okay, if not, thank you, Tomasz. Thanks for enjoying your co-speaker. We will post the presentations on the website just for folks to download and read them offline. The sessions are also recorded in case you want to share it with your organizations. Hopefully by next week, it should be available on our web. Thank you.
Thank you very much.